G'day YouTube. Here's a preview of me CNC machine I'm building. Nearly finished the mechanicals on it. Got the X, Y and Z slides all done. These are just the tools I used here. Just basic hand tools, digital calipers, engineer's square, steel ruler. And over there we got the drill. I had to get that drill. My old pedestal drill was it wasn't quite big enough. It's been an interesting build. We'll see how it turns out when we put all the motors. We're going to run NEMA 23s, NEMA 17 on the Z slide. Yeah, I'm pretty happy with it. That's the first time I've built this sort of machine, so we'll see how it goes. Back side of the little machine. Give a bit of a zoom in. On the top there you see the articulated cable trunking, cable drag chain some people call it. You can also see the gearing down on the Z slide there. Got 5:1 gearing on that for error reduction and also for finer resolution. Here we've got the deck off, and you can clearly see the ball screw drive system. See how I've got it attached to the X gantry there. See the wiring coming from the Y-axis motor number 2 on the rear right. It's the cable ties you see on the front piece of threaded rod there, all thread some of you people call it, booker rod. On the left hand side you'll see more articulated cable trunking and an attachment bracket. And just below that you can see a 20mm fully supported linear rail. I chose mainly use 16mm fully supported slide bearing there. I got the 20mm really cheap, so I grabbed that as well. A little bit heavier, so I put that on the bottom. There's the wiring for the two Y-axis motors and the X-axis NEMA 23 that's yet to be installed. Here's a view of the rear of the machine. Gives you a better look at the ball screw and the attachments and the drive systems. That's obviously another reduction drive on the Y-axis. The all thread rod there, I use that to hold the distance between the two gantry support pieces, and I can adjust that to exactly the right distance apart. And yeah, it's the way to go. It gives you a bit of adjustment. Easy to align your machine. On the gantry you'll see the X-axis ball screw. It's a 1605 type ball screw. 5mm thread pitch. We'll show you, zoom right in. If you have a look at the back of that drive plate, you'll see it almost scrapes the gantry. There's probably about maybe not even 1/2 mm clearance there. It was pretty close, but it doesn't scrape, so that's the main thing. It all fitted in quite well, and the machine is progressing along nicely. I hope to finish it in the next few days. G'day viewers, just another update on my machine building progress here. Today we built this little power supply. See, got a decent sized bridge rectifier there. 100 amp, I don't need that, I need about 50, but 100 is a good safety margin. I don't need the 1600 volt rating that was just there, that's what I got. That's pretty cheap. Put a nice little capacitor in, as you see, 80 volts, 8000 UF I think, microfarads. That's enough. We're getting 50 volts out of that power supply. I run it through the little speed controller there you can see on the desk. That's just manual speed control for the spindle. It's pretty good, very happy. I'll give you a bit of a demo. And as you can see on the machine, we're got an emergency stop button. Crucial piece of safety equipment. Should put it on first, but as you know, you get a bit excited and you want to get your machine running, and yeah, but yeah, definitely going to fit the emergency stop. That's goes without saying. But anyway, we'll see what we can do with the machine now. Now we'll start the spindle up. Give it a bit of a rev.